Okay, hi guys. So here's phase 4. It's the same as what we've been doing, except we're going to do limits from the right. So the directions are given the following functions use a table of values to determine the right-hand limit. So here's the function that we're working with. And a limit from the right, you're going to see a little plus sign up there instead of a minus sign. So I want to think about values to the right of 6. So if you want, you could draw like a little number line. Sometimes that helps. So there'd be 6. 7 is to the right of 6. But we want to be, 7 is actually, if you think about all of the numbers that there are between 6 and 7, there's infinitely many. So 7 is kind of far from 6 if you think of it like that way. So we want to be super, super close to 6. So I'll start like at 6.1. So 6.1 is pretty close to 6. But it's to the right of it. Now I still want to be to the right of 6, but I want to be even closer, so I'll do 6.01, and then I'll do 6.001, and then I'll use my calculator, and I'm going to type in the function, x minus 7 to the third. I want my table to be on ask, which it already is, and then I go here. Now I was already doing like a previous problem, so that's why I have different numbers in, but I could just type over them. So 6.1, 6.01, 6.001, and then you could even go, I'll just write those down. So we've got negative 0.729, negative 0.97, negative 0.997. So it looks to me like we're approaching negative 1. And I'm not going to write down anymore, but I'll put in another one. So this is so 6.0001. Oh, okay, so here's something I noticed, guys. See how when I type in 6.0001, it gives me, in the table, it looks like it's negative 1 exactly, but it's not negative 1 exactly. There's just not enough space here to put all the decimals, so the calculator is going to round it. But if you go on, like if you put the highlighting thing over negative 1, you'll see that what the calculator really computes is this number here. Okay, so sometimes you're going to see that when you're doing these limits, it'll look like it's an exact number, but like an exact whole number, when really if you just put the thing over it, you'll see what the number really is. But it's super close to negative 1. So what we can see from the table of values is that as x approaches 6 from the right, that's what that plus means, the y's are getting closer and closer to negative 1, but they're not passing it. And it's that number you get closer and closer to, but not passing, that's the limit. So the answer here is negative 1. Okay, now I'll do this one. So this time I'm approaching negative 7 from the right. So I got to think about that. So here's negative 7. I'm approaching it from the right. So sometimes it helps to just think of like an integer that's to the right. So that would be like negative 6. So negative 6 is to the right of negative 7, but it's really, relatively far from it. So I got to get right up in there really close. So that would be like negative 6.9. So negative 6.9 would be to the right of 7, but very close to it. Now let me get closer. Let me get even closer. And then I'll type this into my calculator. And I did this on another one, guys. If you use, you know how if you do alpha y equals, and then you could just open up this fraction bar like that. If you do that, then when you go into your table, it's going to give you fractions, but we want to see decimals. So I'm going to instead go x squared divided by x plus 7, but I need to wrap the x plus 7 in parentheses when I do that. And then I can go to my table, negative 6.9, negative 6.99, negative 6.999, negative 6.9999, Okay, so the numbers we've got are 476.1, 4886, 48986. Now guys, look at these y values here. Is there a number, a certain number that they're getting closer and closer to but not passing? And the answer is no. Look how big these jumps are. For every small incremental change in x, we're getting a huge jump in y. And the jumps are going in the positive direction. So what this means is that as x is approaching -7 from the right, the y's are approaching infinity, positive infinity. And positive infinity, it's not a number. What it means is that we just keep continuing and continuing in a positive direction. Okay, so the answer here is infinity. And guys, some people would also say that the limit does not exist, which is true because there's not a single number that we're getting closer and closer to but not passing. But specifically, it's infinity. Okay, now this very last one. This time we're approaching -1 from the right, and this time we have a piecewise function. So here's -1. To the right of -1 is 0, but 0 is, relatively far from -1, so I got to get right close up in there. So like -0.9, -0.9, -0.99, -0.999. Now, if we're plugging these values into this piecewise function, -0.9, -0.99, which piece are we going to use? And so these numbers, guys, they're over here. So these numbers they're to the right of -1, so that means greater than -1. So we're using that part of the piecewise function, x squared. So I go to y equals just x squared, -0.9, -0.99. So blurry. Bothers me. Okay, so we've got 0.81, 0.9801, 0.998. So as x is approaching -1 from the right, y is approaching +1, which means that the limit as x approaches -1 from the right of g of x equals +1. Okay, so there's that.